Hello and welcome to the fourth lesson in our fourth unit, Graphing Quadratics, in our grade 10 academic math course. So far in this unit we've had an introduction to what is a quadratic and some of the key terminology and key features of quadratics. Over the last two lessons we've learned a little bit about vertex form of a quadratic and the things that make that unique. Today we're going to look at a second form of a quadratic, and that is called, and it says it right there in the title, we are going to look today at standard form. And right underneath that we have standard form written down. So it's y equals ax squared plus bx plus c. Now I've already got a couple of little features listed on there, so take a second, copy this down, and then I'll just talk a little bit about the key features that show up in this particular form of a quadratic. So the first thing, of course, is the a value, and what you'll notice between standard form and vertex form, the a value is sitting out front of both of them. And the a value tells you a couple things, as you recall. It tells you the direction of opening. So if it's a positive a value, our parabola opens up. If it's a negative a value, our parabola opens down. We call that a vertical reflection across the x-axis. And this next part is new. Standard form of a quadratic relation also tells you the y-intercept, and it is the constant value at the end. The c value tells you where this quadratic relation is going to cross the y-axis. So we get two useful pieces of information from standard form. Let's see how we can manipulate standard form in such a way that we'd be able to graph it, because unlike vertex form, where you have the vertex and then after that we just apply the plot pattern, here we don't have the vertex being given to us. What we do have though is, and let's look at our first example for this. So we have y equals 2x squared plus 8x plus 5, where AOS is x equals negative 2. So they've told us that for this particular standard form version of a quadratic relation, the axis of symmetry is going to be x equals negative 2. And that's a clue for us. If we can remember, if we're talking about, you don't have to sketch this down, but if we have our graph here, we don't necessarily know what the graph looks like yet, but if I tell you that the axis of symmetry goes through it, I can imagine what the graph's going to look like, in that I know that that line is going to go up the middle of it and the vertex is going to be sitting on that line somewhere. So that's just something that's going to be helpful for us in this form that doesn't directly provide us with the vertex. So the first strategy we're going to use to graph a quadratic relation in standard form is to create a table of values. So I've set one up here for you. What's interesting is that, hopefully you've seen this now, if we have the x component of our vertex, we can substitute that back into the original equation and it will tell us the y component of the vertex, which is really nice. So here, knowing that our axis of symmetry is x equals negative 2, if I substitute that into this equation, which I'm going to do, 2, and that's going to be negative 2 all squared plus 8 times negative 2 plus 5. Now we're a little cramped for space here, so I'm just going to type this mess into my calculator because it's a little bit faster. So that's 2 times negative 2 squared plus 8 times negative 2 plus 5 equals negative 3. Now you can write this out long style if you want. I guess that's not necessarily the big mission today as much as it is creating a table of values. So now that we know what our vertex is going to be, we actually can use what I guess would call strategic points. So knowing that the x value negative 2 is my axis of symmetry, I would consider going to negative 1 and negative 3, which is one step on either side of it, and finding those values so that I can plot them. And then further to that, taking a further step out using 0 and negative 4 to get 2 more points from my graph. So once you know your axis of symmetry, picking a couple strategic points, either 1 step, 2 step, even 3 steps out from your axis of symmetry will give you some nice points to graph around your vertex. So the way that we've set this up, let's do some substitution. So this is going to be 2 times negative 4 all squared plus 8 times negative 4 plus 5. And let's put that into our calculator. 2 times negative 4 squared plus 8 times negative 4 plus 5 equals 5. And we put that into our table. If you'd like to here, you can actually pause and complete this table on your own. I'm going to move through it fairly quickly here. So if you want some time just to work the calculations on your own and ensure that you're getting the correct answers, maybe hit pause here and finish up the table, and then come on back and we'll finish so you can follow along and see how you did. Okay, so for our next substitution, that's 2, negative 3 squared plus 8 times negative 3 plus 5. Let's pop that into the calculator and see what we get. So that's going to give us 2 times negative 3 squared plus 8 times negative 3 plus 5 equals negative 1. And we'll continue with our substitution. That's 2, negative 1 squared plus 8 times negative 1 plus 5 equals, and just because I'm lazy, I'm going to do all my writing at the same time here, 2 times 0 squared plus 8 times 0 plus 5. Well, that one's pretty straightforward because the first and second terms become 0, so our answer for this one is going to be 5. For the one above it, again, if you can use your calculator, that's no problem. That's going to give us 2 minus 8 plus 5. That's going to give us negative 1. Okay, so we've completed our table of values. Now we can go down and we can actually graph this thing. So I know that my vertex is going to be negative 2, negative 3. So I'm going to change up my color scheme here. We're going to put that on. So negative 2, negative 3, right there. While I'm here, I'm going to dot on my axis of symmetry. So that's all the way top to bottom through the vertex. Off we go. Almost there. Very close. And again, I like to label it on the bottom. You can label it on the top. No big deal. X equals negative 2 for our axis of symmetry. And now I'm going to plot those other 4 points that we found from our table, starting with 0 and 5, and negative 4 and 5. Those two are partners, again, across from each other. And negative 1, and negative 3, negative 1. So there are my 5 points for this graph. I'm going to label, actually let's draw the line in here first. So again, we're trying to keep it curvy as much as we can. Curve it up, get some arrows on the end there. Let's label our vertex, negative 2, negative 3. Let's label our y-intercept, that's going to be 0, 5. Our x-intercepts, again, they're falling halfway between a couple of points. Didn't do a very good job of drawing that one, but we don't want to guess at them, so we're not going to guess at what our x-intercepts are going to be, but we can put down the standard form version of this equation. So y equals 2, I think it was, 2x squared plus 8x plus 5. And that is a pretty good looking graph from standard form. Let's try a second example now. Now, table of values, I'll be the first to say, table of values is not my favorite. It's quite, it's just time consuming when you can do it just as easily. So let's have a look at example B here. Y equals negative 2x squared plus 12x minus 11, where our axis of symmetry is x equals 3. So as I said before, if we substitute, so we're going to sub x equals 3 into the equation. And what that's going to do is that's going to spit out a corresponding y value that will give us our vertex. So let's try that. We have y equals 2, I'll erase that, negative 2 times 3 squared plus 12 times 3 minus 11. And again, we're short on space, so let's pop this in. So negative 2 times 3 squared plus 12 times 3 minus 11 equals 7. So this tells me that my vertex is going to be 3, 7 for this particular quadratic equation. Now we already know the plot pattern. We learned how to do a plot pattern when we were working with the vertex form of our quadratic. So let's just sketch that out now, just the plot pattern. So I know that the output values, the going up 1, 4, and 9, for 1 step out from the vertex, 2 steps out from the vertex, 3 steps out from the vertex, this will be amplified by my a value. Now my a value here is 2. The negative just tells me that my parabola is going to open down. So instead of going out 1 and down 1, I'm going to go out 1 and down 2. Instead of going out 2 and down 4, I'm going to go out 2 and down 8. And instead of going out 3 and down 9, I'm going to go out 3 and down 18. So I already know about everything I need to know about this graph in standard form because I've been given the axis of symmetry. So I'm going to start graphing. I'm going to go change up my color scheme here. And let's go put 3, 7 on the graph. 3, 7 on the graph. Let's dot on an axis of symmetry all the way top to bottom through the vertex. Down we go. There it is. And we label x equals 3. Awesome. So now, knowing that my parabola opens down and that my plot pattern is out 1, down 2, out 2, down 8, so 2, 3, 4, 5, 6, 7, and 8. And I don't know if I'm going to have quite enough for 18 there. I'll be a little bit short. So we'll just stop it here. I have all the points that I need. I'm going to sketch my curve between these points. Get some arrows on there happening. And let's start labeling. So my vertex is 3, 7. We don't have good x-intercepts, and we don't have a y-intercept at this moment. The y-intercept, as we can see from the actual question itself, is going to be at -11. So I guess we could actually kind of pop that on there. There's our y-intercept at -11, which means there'll be a corresponding point over here. Oh man, okay, let me redo those lines then, I guess, so I can get them all on there. Okay, so starting there, curvy line. Oh, I even missed the point. That's terrible. It's really hard on the iPad, people, I swear. Up and through, little curve, down, and through. Whew, made it. Let's get some arrows on those things. Let's label that y-intercept 0, -11, and label the equation itself, and then we're finished. So we have y equals -2x squared plus 12x minus 11, I think it was. Yep, there it is. So there is graphing quadratic relations in standard form, given standard form and an axis of symmetry. So again, just at the bottom here, this is just a sort of a summary of what we did, which was if you are being asked to graph a quadratic relation in standard form and they give you the axis of symmetry, you can make a nice little table of values and off you go. You can just plot the points, or you can find the vertex and then use the plot pattern to finish that up. Again, the new thing we learned today is that standard form of a quadratic equation has the y-intercept right in it. It's the c value, the constant value at the end, and obviously it has the direction of opening and the stretch factor in the a value. Good luck with the homework. Again, it's a fair bit of just sort of practicing and graphing. The first part is really just like make tables of values, so grab a sheet of paper and some graph paper and off you go. Those guys are there, and then the second half is using the vertex and the plot pattern to fill them out. So rock through that homework, and we'll see you in lesson number 5.